All right, so hopefully you've tried that problem B. Now let's look at the compound inequalities. So compound inequality consists of two inequalities joined by the word and or. And this is actually really the most important part of the whole thing with compound inequalities. I think about it like this. If you think about like maybe, did you guys ever watch the Bernie Mac show? That's old school, right? It's going back. Okay, remember when he used to talk about his little niece and she would go downstairs and she'd say, I want some milk and cookies, right? So anyway, would she be happy if she had just milk or cookies? No, she wanted milk and cookies. So the word and in math is like that bratty little 2-year-old that is not going to be happy unless both things are true. Okay, so and implies the solution satisfies both inequalities. You must wash your dishes and clean up your room before I get back. You better do both. Or implies that a solution satisfies one of the inequalities. So you better wash your dishes or clean your room before I get back. Either one will do. So if she had said, I would like milk or cookies, you could give her either one and she would have been happy, right? So if we look at this here, we want to see are these compound inequalities true or false? So 1 is less than 3. Is that true? Is 3 less than or equal to 5? Also true. Because you can say, when you say even less than or equal to, either thing can be true. That word or implies that if either thing is true, that's fine. So this one would be true. And then here, this says 1 is less than negative 3. Wait a second. Is 1 less than negative 3? No, that one is false. Even though 3 is less than or equal to 5, this part here would make it false because both things are not true. Negative 2 is less than 0. 0 is less than negative 1. True or false? Well, one part is true. That part is true. But this part would be false. So that makes the compound inequality true or false? False. Okay? 1 is a solution to x is less than 3 and x is less than or equal to 5. Is that true? 1 is the solution to x is less than 3. Isn't 1 less than 3? I would say that's true. Wouldn't you? Oh, wait. I'm reading it wrong. Why aren't you guys correcting me? Yes, x is greater than 3. Okay. So actually that's false. Good job catching my mistakes here. 3 is less than 3. Wait a second. Is 3 less than 3? 3 is not less than 3. 3 is less than or equal to 5, but because 3 is not less than 3, we call this one false. 0 is a solution to 3x is less than negative 3, and 2x is greater than or equal to 3. So if we plug in 0, or there's a couple ways we can do this. We could solve these for x. If I want to simplify this a little bit more, I could divide both sides by 3. I get x is less than negative 1. Is 0 less than negative 1? No. What if I divide both sides by 2? Here, I get x is greater than or equal to 3 halves. Is 0 greater than or equal to 3 halves? No, so we would say this one is false. Negative 1 is a solution. Another way I could do this is plug in negative 1 and see if it works. If I plug in negative 1, I would get 4 is greater than or equal to 6. If I plug in negative 1 here, I would get negative 3 is less than or equal to 3. Is either one of these things, so actually this says the word or here. So since it says or, it didn't work for the first one. That one's false. But it did work in the second one. That one's true. So would we say that one is a solution for this or this? Is that true or false? That's going to be true because it's working for one. That's the example of I can have milk or cookies, and if I have one of them, then I can call it true because of the word or. Okay, so looking at this on the graph, if we were going to solve a compound inequality, -1 is less than or equal to x is less than 2, we would graph the solution, express the solution in set builder and interval notation. So the compound inequality, which means x is greater than or equal to -1, and because it's all together, we're going to be using the word and, x is less than 2, we can use a number line to graph the solution. So we first start by graphing x is greater than or equal to -1, and then and x is less than 2. And this place where it's double shaded, this is where our solution set is. Because we're using the word and, we want to have both things be true. Both things are true wherever there's a double shaded area, because all the numbers that are greater than or equal to -1, but also less than 2, are going to be in our solution set. So that gives us our interval. You can see that the compound inequality, it's already solved for x, and so that's what's going into our set builder notation, and then our interval can come from the graph of the and. Okay, so the definition, if for any two sets, A and B, the intersection, and that word intersection refers to and, of A and B is denoted by A and B is defined by A and B, X is an element of A and an element of B. So basically this is where they're intersecting, okay, because I can't have or either thing be true, I need both things to be true. That's why we call it an intersection, as opposed to with or statements we use union. Any questions about that? I feel like that was a long-winded explanation.